All right, let's look at another problem here. Going back to Venn diagrams and another problem, we can work on that. Let's suppose the number in A is 15. The number in B is 19. And the number in A intersection B is 3. And one last detail, the number in the union is 40. Okay, that's the information provided. Here's what I want to do. Find the number of elements in each part of a Venn diagram, Find the number of elements in each part of a Venn diagram. Kind of a little different twist on the things we've been doing, but similar in a lot of ways. Okay, so I want to draw my Venn diagram, which has two sets, so the interlocking Venn diagram. Here's the story. What I want to do is figure out how many parts or how many elements go in each part of that. I don't know the set, so I'm going to have to figure this out just from the numbers here. Let's think about it, though. The number in A is 15. That tells me the total in the A circle is 15. 15 elements don't go right here, because why? Well, A is comprised of two parts. It's this part and this part. So all I can say from the number of A being 15 is that those two parts add up to be 15. And I can add up to be 15 a lot of ways. 13 and 2, 10 and 4, or 10 and 5. All right, so I can't very well use that yet. The number in B is 19, same problem. I know there's 19 in the B circle, but there's two parts to the B circle. I know they need to be added up to be 19. Yeah, if I move to the third one, hey, I'm in better shape there. Because what does that tell me? The number in A intersection B is 3. And where is the A intersection B? Right here in the middle, isn't it? So I definitely can say 3 elements go in the middle, because that's what that tells me, right? Okay, now what does that do? Well, that opens up back to these two, doesn't it? Now I can go back to the number in A is 15, because now I know this part's 3, so what does this part have to be? 12, because, yeah, the 2 need to add up to be 15, so this is 15 minus the 3, so that gives me 12. And since the number in B is 19, that means these two add up to be 19. So 3 plus what gives me 19? That'd be 16. Okay? So I figured out 12 elements are in here, 3 elements are in here, 16 is in here. That leaves only the outside part, the fourth part there, to be determined, which I've used this one, I've used this one, and I've used this one, so that one must have something to do, the way I can find. All right, the number in U is 40. What does that mean? Does that mean 40 go out here? No. 40 does not go out. The number in U means the total of everything. So that means if I add up this, and this, and this, and this, I get 40. So the 12 plus the 3 plus the 16 plus the outside part needs to be 40. That's what that tells me. The universal set's everything. Not just the outside, the universal set's everything. So what do I need to add to get 40 in the case there? That's 15, that's 31, be 9, wouldn't it? That needs to be 9. So that tells me this needs to be 9. by that? So we've got it. Questions or concerns? Okay. Well, let's bump it up a notch here. Okay. Let's say, everybody got that? Similar problem. I know, let's see which one. This one's out of the book. So. All right. Let's say I know the number in A is 57. The number in A intersection B is 35. The number in A union B is 81. The number in A intersection B intersection C, added a C there. Okay, we got 3 sets in this case. The number in A intersection B intersection C is 15. The number in A intersects C is 21. The number in B intersection C is 25. The number in C is 49. And the number in B complement is 52. See if I got all those written down right. 57, 35, 81, 15. Yep. So again, same scenario here. Find the number of elements in each part of the Venn diagram. Of course, the deal is I've got A and B and C Venn diagram, don't I? So we got 3 rings. 3 ring circuits here. Okay? Got an A and a B and a C. Well, as you can tell there, you need a bit more information to do it for a 3 set. Matter of fact, you need 8. A while ago we had 4 pieces of information. Here we need 8 pieces because there's 8 regions, isn't there? That's kind of a link there. But anyway, see if we can figure out what we need to do. Can I start here? The number in A is 57. Well, obviously no, because A is made up of many pieces, 4 pieces, matter of fact. So that 57 is going to be divided amongst those, right? I don't know how to do that because there's lots of ways you could do that. I don't want to just try to guess. And matter of fact, I can't even start here with this intersection because A intersection B is the overlap between A and B. And you see here that it is 2 parts now. So it's 35, but how are you going to divvy it up? You got to go elsewhere. Where would I probably going to start? How about right here? The number in A intersection B intersection C is 15. That's the overlap of all 3 circles, where all 3 circles overlap, which is where? Right in the middle, yeah. This is the number right in the middle. That's where all 3 are overlapping. So I know that one's locked in to be 15. With me, okay? Okay. Now where? I can go back now to this one, can't I? We talked about that one. A intersection B is 35. Well, that's these 2 pieces, here and here. And now I know this is 15. So doesn't that make that one be 20? Because they have to be total of... Okay. We've used that one. Use that one and use that one. I still can't go with A yet. Why? A is 4 parts. I know 2 of them. I still don't know 2 of them, though. So I can't use it. This one is still not in play yet. A union B, because that's everything in A and everything in B, which is all of this. So that's 6 parts. I only know 2 of them. But I can go to more of these intersections here, right? I can go to this one now. A intersection C is 21. Where's that? That's the overlap of A and C, which would be right here, wouldn't it? These two right here is the overlap of A and C. Don't forget that part. So that totals to be 21. 15's here, so that must mean 6 here, right? B intersection C is 25, so that's the overlap of the B and C circle. B and C, so B and C overlap right here, these two. That totals be 25, so must be 10 right here, right? All right. So we got a good start. We got 4 of the pieces out of the 8. Where to now? Well, I can jump right to this one, can I? The number in C is 49. That's the total, all total of the C circle. C is right here. That totals up to be 49. So 6 plus 15 plus 10 plus then this outside part there has to be 49. Well, I know 3 of them, so I can figure out that last one, can't I? This must be here, basically what these add up to be, and then subtract 40 from 49. That's 21, that's 31, those 3. So how many go here? 20, 30, 25, 31, 18, yes. Is that okay? Everybody see where we get that? So I've used that one. Okay, now we can go back to A2. We could have done it maybe earlier too, but now I can do this one, because just like that one I had 4 parts, but I've got 3 of them locked in. I now know this is 20, this is 15, and this is 6. So altogether those need to be 57. So 20, 15, and 6 is what, 41? 20, 15, and 6 is 41. And then needs to be 57, so this needs to be 16. Sound right? Okay. All right. Well, we are almost done. Notice we still got this part and then the outside part. Well, let's see what we can do with this. The number in the A union B is 81. Union is what? Union is everything in this set combined with everything in this set. So A union B has 16, 6, 20, 15, 10, and that. Everything in those 2 sets. Which is 6 parts, a lot of parts, but the good news is I only know, I know all of them except one of them. So I can figure out that one. Doesn't this have, these all have to add up to be 81, so I can figure out this. What have we got here? I think these should be 57. So I think these 5 add up to be 67. Check me on that, but I think that's right. 67, those 5. So what goes here? 14, 16, 20, 6 and 15, and 10 gives me 67. So that means 14 go here because those all add up to be 81. A union B is all 6 of these. Not the 18, yeah. The 18 is not in the union of A and B because it's not in A or B, is it? I'm only adding up the parts that are in A and B. Those added to be 67. Did anybody check me on that? Make sure. That was 67, okay. So that has to be 14 there because that gives me 81 all total for those circles. All right, well, there's still one piece left, and there's still one unknown part, so that's good. I can figure it out, hopefully, by that. What have I got here? B complement, the number in B complement is 52. What does that mean? Well, that's the number of elements total outside of the B circle. In other words, if I cover up the B circle here, that needs to be 52. Well, I've got what? 16, 6, and 18. That's 40, I believe. So if these are 40, what goes out here then? Because that's also on the outside. Well, it needs to be 52, so if those are 40, this needs to be 12, doesn't it? There you go. So it's just kind of a putting the pieces of the puzzle together problem. How's that? Question or concern?